Hello everyone. Today we are going to talk about the interesting sampling idea called inverse transform sampling. So we are going to give you some intuitive understanding of how it actually works, and why we need the sampling and how we can use that for like practical problems. So why do we need to do this kind of inverse transform sampling? The main reason for that is we wanted to sample sometimes we want to sample in a complicated probability distribution. So, for example, the Gaussian distribution or some other even more complicated distributions. So we wanted to have a way to get samples from those distributions. Okay, so before we dive into the uh, the inverse transform sampling, we need to understand why we need sampling in the first place. So here I give an example of Bayesian parameter estimation. So suppose we have a model which with the parameter theta, and we are given some data d, and theta is here. Theta refers to to probability for a machine learning model, for example. And given data d, we can compute the posterior probability for theta, which is p theta given d. And then if we want to get the expectation value of theta given d, then we need to compute this integral. So it's basically calculate the integral of theta uh, in the distribution of this under this posterior distribution. But generally, this posterior distribution is very complicated. So this integral does not have a like analytical form. So we have to rely on sampling to solve the problem. Basically, the idea is that we sample in this complicated distribution. For example, if we take n samples and we calculate their mean, which will be a good estimate for the expectation value. Okay, so that's why we need sampling. And before we do the inverse transform sampling, we wanted to have a assumptions. So the assumption here is we can always sample from uniform distribution from like U0 to 1. This is because there's a lot of like existing way to generate pseudo numbers between 0 and 1 such that the generated samples follow a uniform distribution. So that's very easy to do. There's a lot of methods to do that. And our question is, given that we are able to sample from a uniform distribution from 0 to 1, how do we sample from any distribution? For example, this distribution is complicated. How do we actually sample from this distribution? So when we think about this problem, the first thing we need to know is the probability of sampling any sample is proportional to the probability density at that sample. For example, if we take these 2 points, x1, x2, the probability of getting x1 as sample divided by probability of getting x2 as sample is equal to the probability density at x1 divided by probability density at x2. So this is a basic foundation we need to really understand to have a to be able to sample from this distribution. Okay, so given this foundation, we can actually look at how we want to sample of x from this probability distribution px. So the way we do that is called grid sampling. The idea is that we wanted to divide the area under this curve, under this PDF curve, into a bunch of equal-sized grids in this case. So in this case, we have we divide the area under the curve into 20 grids. Okay, so we number these grids from left to right. So we have 1, 2, 3, 4, 5, 6, all the way to 20. And because these grids have the same size and same shape, each grid had the same probability of being selected. Okay, so now the problem of sampling from P of x becomes the problem of sampling a specific grid among these 20 grids. Okay, so, and also we know that these 20 grids have the same probability of being sampled because of this. They have the same size and same shape. So the problem basically becomes, we want to generate a number, we want to generate an integer from 1 to 20 with an equal probability. So because each number has an equal probability of being selected, we can use uniform sampling to generate the index we want. Okay, so basically we want to generate a sample from uniform distribution 0 to 1. For example, if we get 0.4, then we multiply this one by the number of grids, 20, so that we get the grid number, a grid index 8, which is the grid being sampled. So once we get this grid, we can find this corresponding x prime. So this x prime is the sample we want to generate from P of x. Okay, so that's the general idea of grid sampling. So how do we go from here to the inverse transform sampling? So if we think about this problem, if we think about what we are doing here, okay, so we are basically trying to find a grid number, which is 8 here, with 40% of the grid on the left-hand side of this grid. Okay, so in this case, if we draw a vertical line here at x prime, then there are 8 grids on the left of this vertical line. So basically, we're talking about 40% of the grids are located on the left-hand side of this vertical bar. And if we look at this, we're basically saying that on the left-hand side, on the left-hand side of this area under the curve, the 40% of the area is located on the left-hand side of this vertical bar. Okay. And what does this mean? It means that the cumulative distribution function, which is the area under this curve, so which is area under the curve here, is 0.4. It means that the CDF at x prime is equal to our sample 0.4. Okay, so if we understand this, it's pretty straightforward to go from grid sampling to inverse transform sampling. We don't need grid anymore. We just need to sample from a uniform distribution 0 to 1 and get a sample y. And then we find x prime with the CDF equal to y. So that's inverse transform sampling. We wanted to find a sample with the CDF corresponding to the sample from the uniform distribution. That's the basic idea. So once we have this inverse transform sampling, we can sample from any distributions as long as we have its CDF. So instead of only sample from the uniform distribution, we are able to sample from a wider class of the distributions. For example, we can sample from Gaussian distribution. So by using some tricks. So that's something we are going to talk about next. So yeah, that's basically what I want to talk about today. And let me know if you have any questions. Leave a comment below. And thank you so much for your attention.